Welcome back. Now things are looking pretty good so far, but our drone is only firing a single blaster beam after a single delay. If we go to BP bot on begin play after we've stored our target pawn, we have a delay. I set it to 8 seconds, and then we spawn a single blaster beam. Now delays are okay, usually for testing, but in serious code we don't typically use them all that much, and that's because they're not easily controllable. If you start a delay, then whatever is hooked up to completed is going to execute no matter what. We can't cancel it, we can't stop it, and if certain references become invalid by that point, we'll be trying to use them when they're invalid and so on. So delays are kind of primitive, and there are better, more sophisticated methods to doing things. One of those better alternatives is to use a timer. A timer allows us to execute some functionality after a specified time. Let's give a timer a try. I'm going to right-click just under our delay node, and I'm going to call set timer, and we have a number of options here. We're going to start with set timer by event. Now, set timer by event has input and output execution pins, of course, but notice one of its inputs is event. And if we hover over it, it says event delegate. Delegate is just a fancy word for event. It's actually the C++ word for it. Delegate comes from programming terminology, but this node takes in an event. Now, you may have noticed if we go back to event begin play, it has one of those square red outputs. If we hover over it, we see output delegate. So events have their own values, just like other types of values in the event graph. We can right-click and search for event tick, and we can see that even the tick event, which we're using down here, has one of those red square outputs. So set timer by event requires an event, and it's going to execute that event based on some period of time that we specify. So I'd like to use this instead of our delay node. So I'm going to take that delay node and simply delete it. And instead, we'll use set timer by event, and we just need to figure out what we're going to hook in for our event. Well, we can create a custom event. We can always create our own custom events in the event graph by right-clicking and typing custom event and using add custom event. Now the name is highlighted, expecting us to give it a meaningful name. I'm going to call it Fire Blaster Beam. And if you don't like the name, you can always click on the name and rename it. You can also click on the event node itself and go to the details panel and rename it there. And we now have a delegate of our own. We have our own event called Fire Blaster Beam. And executing an event is a lot like calling a function. We can always right-click and search for the name of that event. In fact, we see it under call function here. If we get that, we have what looks like a function call, but we're actually executing whatever nodes are hooked up to this event. I'm going to go ahead and delete that. Now, our set timer by event needs to know what event to execute at the end of the delay time. So we're going to hook up that value that comes out of the red square output to the red square input to set timer by event. And we also want a time. And notice under time, there's a checkbox for looping, which means that this delegate will be executed every time seconds. But that's only if this is set to true. But I do want this to loop, so I'm going to check that looping checkbox. Now, max once per frame is only if our time is very, very small, but we're not going to be executing this event that fast. I'd like to execute it, let's say every 0.2 seconds. I'm going to enter 0.2 here, but rather than hard code this value, it's generally better practice to not hard code magic values like this. So I'm going to promote this one to a variable and call this blaster time. And this is combat related, so I'm going to take blaster time, I'm going to hit compile first to make sure that its default value is 0.2, like I want it. And I'm going to change its category to combat. Now it's there in the combat category. And now we don't have to go and find the nodes that are using this time. We can always find blaster time as one of the member variables to this class and change it in the details panel. Okay, now what do we do when fire blaster beam is called? Well, we're going to want to spawn a blaster beam, right? So I'm going to bring this down here and hook it up to fire blaster beam. And now as soon as set timer by event is reached, we're going to wait by this amount of time. It's called blaster time. That's 0.2 seconds. And after 0.2 seconds, we're going to get fire blaster beam executed, which will spawn a blaster beam. Of course, it's only going to spawn at the left rifle socket, but one thing at a time. Let's just get this working. So I'd like to see what this looks like if we go ahead and press play. And look at that. And now we can really see the effect of the attenuation if we get really far away. And we can see that that sound is getting louder as we get closer. And we also see the effect of our drone really slowly interpolating its rotation to us. We can see that it's kind of hard for that drone to hit us because it takes so long for it to orient so that it's facing us. That gives us a reason to adjust those interpolation parameters for the drone's rotation. But we'll get to that. For now, I want to focus on the fact that our drone is only firing the left rifle and not both. As we can see. It's a little hard to see, but it's only firing the left rifle and not the right rifle. Now, I can't really see that well because it's so dark down here, so I'll fix that really quickly by going to my skylight. The skylight affects the lighting even in the shade. And I can go down here and adjust my light with my skylight selected in the outliner. Down here in the details panel, I can change the intensity scale. I'm going to try a value of about 3, maybe 4. And as we can see down here in the shade, it's a little bit brighter. Okay, so we have this problem, right? Our drone is only firing the left rifle, as we can see here. We want to fire both, and I'd like to fire them one after the other. First the left, then the right, then the left, then the right, and so on. Now, it's a little hard to play test and see what's going on while we're possessing a pawn and our drone keeps orienting towards the pawn. So I'm going to click the 3 dots next to our play icon and select Simulate. As soon as we do this, we'll be playing the game, but not possessing a pawn. We won't spawn that default pawn, so our drone won't have anything to orient to, but we still get to see the game playing out, and we can spectate what happens. So I'm going to simulate. And I'm going to go above our drone just to see what it looks like. And we can see that our drone is firing only the left rifle. And we want to fire both, right? Okay, so let's go back to BP Bot. I don't need these other tabs open, so I'm going to right-click on BP Bot. Before it lets me do that, I have to save everything. And having right-clicked on BP Bot, I can close tabs to the right. And now we just have BP Bot. So, how do we get our bot to fire first out of the left socket, then out of the right, and alternate between the two? Well, there's a handy blueprint node for doing things like this. It's called flip-flop. If we search for flip-flop, we get a flip-flop node. And this node remembers every time it's executed which one out of A or B was executed last. The first time it executes A, and the next time it executes B, and it remembers the last one so that it can flip-flop between the two every time. It's a pretty nice node. Let's see how we can use the flip-flop node when it comes to spawning a blaster beam. First, I'd like to spawn out of the left rifle, so we're going to hook that up there. But I'm going to Control D and duplicate these nodes, except I don't want the rifle socket name L this time. I want rifle socket name R, so I'm going to bring that in and hook it up to B. So we know we're going to fire the blaster beam every 0.2 seconds. And the first time it's going to use rifle socket name L, and the second time it's going to use rifle socket name R, and the third time it'll go back to L, and the fourth time back to R, and so on. So let's see what that looks like. Let's go ahead and simulate. And we can see that we're alternating. Pretty nice. Excellent. So we now know how to set a timer. Now, it's not entirely obvious, but as soon as set timer by event gets executed, we do wait the amount of time specified here, passed into time, before our event is executed for the first time. We can see that by increasing that blaster time to a higher value, such as, let's say, 2 seconds. If we go ahead and press play, we expect to see that blast happen right away, but we had to wait 2 seconds. We didn't get it blasted right away. So if you want to fire that event off right away as soon as we reach this set timer by event node, well, we know how to call fire blaster beam. We can simply get our search menu and search for fire blaster beam and call that function there. And then we'll get this event executed right away, as we can see if we simulate. So if you want that event fired off right away without having to wait that time, just simply call that event, and we do that the same way we call functions. So I'm going to set my blaster time back to 0.2 seconds, and we now have our drone firing the left and the right rifles, and that's pretty nice. Now, you might be tempted to highlight all these nodes and right-click and try to collapse to a function. And if you try to do that and you try to compile, we'll have some compiler results here with an error. And we see could not find function named Fire Blaster Beam in BP-bot-C, compile failed. And you can't go and try to play because we see blueprint bad. If we press play, we get an error, and if we try to play in editor anyway, well, nothing happens because we have a bad blueprint here. So we have to go back and hit Control-Z to undo that, because there are certain things that we can't do inside of functions. Setting timers is one of those things, and defining our own implementation for our custom events is another. So we can't collapse all of this into a function, but we can make sure to manage our nodes and make sure that they don't get too out of hand, so we'll maintain our nodes as we go on. So excellent job. And before we wrap up, I want to show one last little detail that I'd like to change, and that's that if we press play, we'll notice that those Niagara systems are they look kind of weird. We expect those particles to blast out in one direction, but instead they blast out in all directions. If we'd like to change that, we can edit that Niagara system slightly. So we'll make a little bit of a tweak to that. We can go to Assets, Effects, NS Beam Burst, and we can take a look at the velocity that we're adding from a point. We're adding a velocity from the center, but we can offset the origin of that velocity by, let's say, moving about 10 units in the negative x direction. If we do that, take a look at what's going on here in the viewport. I only did this for the omnidirectional burst, which we can isolate, and we can see that now we're firing in a specific direction, the positive x direction for this Niagara system. So I'm going to disable isolation for that emitter and go to the next one, which is this omnidirectional burst, and go to add velocity and change the origin offset to have an X of -10. And now we get a more directional burst for this emitter. And we can isolate the third one, which does have an omnidirectional. We can set its add velocity origin offset to -10. And now it has a direction as well. And now if I show the entire thing, this is what it looks like. And we can see what it looks like in the game. And that's looking pretty nice. And of course, you know how to adjust these parameters if you want this to look a little differently. I encourage you to play with these any chance you get. This middle one is a little bit yellow for me, so I might go to initialize particle and change it to have a little bit more red by setting that green down to about 20, maybe even 10. And it's a little bit more fire colored. Play around with it, see what makes you the most happy with it, and of course look in the game as well. And one little tweak, this middle part, don't forget to disable isolation before you check it out in the game. Okay, so tweak that to your heart's content until it looks great. Great job, and I'll see you in the next video.